Lesson 80. Somebody asked a question here earlier when our next test would be. At earliest, it will probably be next Thursday. Okay. The way things look right now is that we will review in class on Monday. I'm going to have you evaluate test on Tuesday, and we will finish reviewing on Wednesday with your test on Thursday. Does that make sense? Okay. All right, so this would be the last lesson in terms of that information that we need to go over. This here is where we're at, is lesson 80. What we're talking about is finding the norm of distribution, okay? And I do think that this is a good lesson even to get into before we start really focusing in on preparing for EOC testing, which I know is not everybody in here, but it's important for the couple people I do have in here. Okay, because you might still see stuff like this. So I'm kind of glad that we're still covering some new information rather than just sitting back and trying to hone in everything else that we've learned. All right, for any normal distribution, about 68% of the data lies within one standard deviation of the mean. About 95% of the data lies within two standard deviations of the mean. About 99.7% of the data lies within three standard deviations of the mean. Normal distribution can vary, but we're going to follow a bell curve of 68, 95, 97. And that bell curve is going to look like this. In fact, I'm going to go a couple of slides past so that I can show it to you. All right, so let's say we have a set of data. Now, we should already know what mean is, right? Okay, what is mean? The average. Add all the numbers up, divide by however many numbers there are. We've already used our graphing calculators to find standard deviation, right? It shows up as a symbol that looks kind of like this, right? In our graphing calculators, when we plug in data and we hit those one variable statistics, we're going to find that as my standard deviation. So given a set of data, that standard deviation is going to be pretty important. Now, what they're going to give us today is they're going to tell us what the mean of distribution is. And that's going to be my middle number, all right? But beyond that, right, we're going to have a number to the left and to the right. And this is going to represent one standard deviation. Okay, so if the standard let's use some numbers just as a for instance. Let's say that my norm of distribution was let's use a pretty basic number. Let's say that it was 4. 4 is my mean of distribution. Let's say we have a standard deviation of 2. Okay, my standard deviation is 2, which means my first standard deviation over here is going to be 6, and one standard deviation to the left is 2. You follow me? All right, now I can go one more standard deviation, and this is going to be 2 standard deviations. Now, I don't double it, but what I do is I continue to add 2. So this is 8. Okay. 2 standard deviations to the left is 0. Okay. And we're going to go as far as 3 standard deviations and no further. Okay. So if I keep going, okay, let's take this and continue on out here, right? I'm going to go 3 standard deviations. What's my number off over here? 10, okay? And over here, 3 standard deviations is going to be what? -2. Now, what they're showing you in that slide that we just looked at is that one standard deviation from here to here is going to cover 68% of my data. Is going to fit one standard deviation from my norm of, or my mean of distribution. Okay? Now, then they tell me that on the second one, the standard deviation, 2 standard deviations is going to hold 95% of the data. Okay? 95. And then the 3 standard deviations is going to hold 99.7%. Okay? And this is what we look at. 1 standard deviation, 68, 2 standard deviations, 95, 3 standard deviations, 99.7. This is our bell curve that they're talking about. Okay? So we're going to use this kind of again and again to solve different types of problems and answer different questions about data. So we understand this so far? Great. All right, let's take some steps back here. All right, so 68, 95, 99.7. Standard normal distribution. A standard normal distribution has a mean of 0, a standard deviation of 1. Now, granted, we used a standard normal distribution of 4 with a standard deviation of 2. But the value of a data point on a standard normal distribution is called a z-score. It's a standardized value, and its absolute value is equal to the number of standard deviations it is away from the mean. So we can find out how many standard deviations away. And that can be a decimal. A z-score can be a decimal. Okay? And we have a way of calculating a z-score. Okay? My calculation for a z-score, in order to find a z-score, is this right here. We take our number and we subtract the mean. Then we divide it by the standard deviation. Okay? So let's go back to our other question, for instance. And let's say that I wanted to know what the z-score of 7 was. Right? So if I want to know what the z-score of 7 is, okay, z-score, it's going to be equal to 7 minus, what was my mean? You remember? What was my mean? What's my mean here? 4. So I'm going to do 7 minus 4 divided by, what was my standard deviation? Boy, I don't have very good memories. What's my standard deviation? What's the value of my standard deviation? 2. Okay? 2. All right, what's 7 minus 4? 3. What's 3 divided by 2? You guys aren't impressing me today. What is it? 1.5? So I have a z-score of 1.5. Means it's not exactly at 1 standard deviation. It's not exactly at 2 standard deviations. It's somewhere between 1 and 2 standard deviations. You follow me? Okay. All right, so 1.5. Okay, from here, let's answer some questions. Okay, do we have this document? Did this get sent to you? Okay, so we've got this. Okay. All right, so at this first part here, it says a set of scores is normally distributed with a mean of 53. So if I was drawing this out, 53 would be in the exact middle of my graph. A standard deviation of 6, so that means I'm going to add 6 3 times, and I'm going to subtract 6 3 times. Between what two scores do 68% of the data fall? 68% of the data is how many standard deviations left and right? 1 standard deviation left and right. If my standard deviation is 6, what do I need to do to 53? I need to do 2 things. Subtract and add. So I need to subtract 6 from 53, and I need to add 6 to 53. All right, well, what's 53 plus 6? 59. And what's 53 minus 6? 47. So it's going to be between, 68% of the data is going to be between 47 and 59. Now, I'm guessing by the overall quietness of asking that question that how many of you don't understand what we were doing there? Nobody's going to raise their hand. So what I'm going to do is I'm going to go back over here. All right, wrong one. Let's get this guy. All right, so what we were saying with this, okay, all I have to do is erase that, is my mean was what? Or my norm was 53, right? So 53, add 6, I'm going to get 59 and 47, right? 68% of the data is between 47 and 59. Does that help you out? Okay, if they were asking for how much of the data is in 95%, I would have to add another 6, right, which would give me what, 65? And I would have to subtract another 6, right? So that would be what, 41? So if they said how much or what range of values holds 95% of the data, we would say between 41 and 65. Does that make more sense? We're getting it now, hopefully a little bit. Okay. All right. So if you have to, go back and redraw that bell curve. Question number 2. I got to erase some things here. Okay. A manufacturer finds that the life expectancy of its best-selling model of dishwashers is 11 years, and the standard deviation is 1 year. What percent of dishwasher models will last from 9 to 13 years? Okay, well, let's draw our chart, right? What number goes in the middle? 11. Okay? Standard deviation is how many years? Plus or minus 1. So this is going to be what to the right? 12, and this is going to be 10. Okay, let's do another one. That's going to be 13 and 9. Let's go all the way. 14 and 8. Okay, so we get this guy, and this guy. Okay? All right, what percentage of dishwashers will last from 9 to 13 years? So what percentage is it from 9 to 13? 95%. Okay, or about 95%. Because we know it goes 68, 95, 99.7. Okay? We follow? Great. All right, 3. The heights of 1,250 students at a local school were recorded and found to be approximated by the normal curve below. Identify the mean and the standard deviation of the data. Well, what's the mean of this data? 69, right? Because that's in the middle. It's between 68 and 70, correct? Okay. So we can say, well, we know it's going to be 69 right there. But there's more than one 69 option, right? It's either 6 or it's 3. Now, what they're showing you here is that this is one standard deviation. This is the second standard deviation. And this is the third standard deviation. All right? So how do I find what the standard deviation is? Right? I could take 69 minus 66, or I could take 72 minus 69, right? Probably easier to take 69 minus 66, correct? All right, what's 69 minus 66? 3. So 3 is my standard deviation, right? Or you could have just counted 66, 60, or 67, 68, 69, just counted, right? And saw that. So, sorry, I made that probably a little harder than it needed to be. So we should get 69 and 3. Do we follow that? Okay, pretty easy. All right, now they're going to start talking about z-scores, right? And z-scores we actually have to have a formula for, right? Does anybody remember what that formula was? X minus mean divided by standard deviation. Okay, great. So you guys have that. In a certain normal distribution of scores, the mean is 30. We know we're going to need that. The standard deviation is 4. We're going to need that. We want to find a corresponding z-score to a score of 26. All right, so what am I going to write here? 26 minus 30 divided by 4. All right, 26 minus 30 is what? Negative 4. What's negative 4 divided by 4? Negative 1. My answer is what? D. Okay. All right, was that doable? Good. As long as you remember what we need to do. All right, let's see. 8 questions. We're 4 down. All right. The weights of candles produced in a factory have a mean of 9.5 ounces, standard deviation of 0.4 ounces. A randomly selected candle weighs 9.94 ounces. How many standard deviations is this above the mean? Okay. Let's see. All right, so there's some ways to look at this. Okay, the weights of candles produced have a mean of 9.5. 9.5. Standard deviation of 0.4. Okay, so one standard deviation is going to be what right here? 9 point what? 9.9. Over here, 9.1. Correct? Okay. All right. So what we're actually going to do with this, or what I'm going to do, is we're going to take 9.94, and we want to subtract the mean. The mean was 9.5, right? Okay, and we're actually good. What they're actually asking for, because the z-score, let's go back and actually look at what a z-score is. Okay, what is a z-score? Okay, well down here, the value of a data point on the standard normal distribution is a z-score. It is a standardized value, and its absolute value is equal to the number of standard deviations it is away from the mean. So what we're actually asking to solve for here is the z-score, right? We're saying how many standard deviations. So if they ask me how many standard deviations is something, what they're saying is, what is the z-score? Does that make sense? So we're going to take 9.94 minus 9.5 and divide by what? 0.4. Okay? What's 9.94 minus 9.5? 0.44, right? What's 0.44 divided by 0.4? 1.1. So our answer is 1.1 standard deviations. Okay? Okay, 1.1. That makes sense? Okay? When we understand the definitions, like what is it, not just how do I find a z-score, but what is a z-score to begin with, that's really going to help in knowing when to find it, or when I need to use that formula. Okay, do we have that down? Hopefully. If you don't, let me know. It's too late. Okay. 6. Okay, 6 has a lot of stuff here. Okay, but it's not impossible. It's just we're going to come down. I'm going to actually scroll down to the bottom so we can work this out. Do you guys still have this in front of you so that you can see it? Yes? All right, so I'm going to read it, even though, well, I'll read it and then we'll scroll down. All right, students took a test consisting of math portions and a science portion. The scores for the math portion are normally distributed with a mean of 41, standard deviation of 6. The scores for the science portion are normally distributed with a mean of 66 and a standard deviation of 8. Our questions are going to be based upon that. So what we want to do off at the beginning is we want to create two separate bell curves. Okay? We're going to create a science curve, or a science curve and a math curve. Can we do that? All right. So we should have a norm of distribution on both. Let's call this science and math. Okay? What was the norm of distribution for science? 29? 41, sorry, 41. And what was the standard deviation? Was 6? 6. Okay. Oh, okay. So we're getting math and science confused then, right? All right, well, let's start. Which one comes first, math or science? Math. So let's start with math, okay? 41, right? And with a standard deviation of what? 6. So my standard, or my 68 is what? 47 and 35. Okay, let's do another one. Okay, 53 and 40 or 29. Okay, take a little bit further out here. What, 59 and 23. Okay. All right. What about with science? 66 and 8. All right, so one standard deviation, 66 plus 8 is what, 74? Is that right? And what, 58? 58. Okay, let's go another one out. 74 plus 8 is probably what, 82? Okay, and 50 down here. Okay, 90. And we're going to extend this out here a little bit. 30, 42? 42. Okay. All right, now I could make all the curves, but that's not really necessary for this. All right, let's look at question A. A says, Natalie received a score of 47 on the math portion. Okay, on the math portion over here. How many standard deviations away from the mean is Natalie's score? 1. She's exactly 1 standard deviation away, right? 1. Are we good with that? All right, let's look at B. What percent of the math scores between Natalie's, let's see, what percent of the math scores are between Natalie's score and the mean portion? Okay, well, she scored a 47, right? This represents 68%. So our question is, what percentage of this class was between 35 and, oh, I'm sorry, I messed that up. Let me clear this up here a little bit, because we should be from here to here, right? This is 68. Our question is, what percentage of students are from 41 to 47? What do you think? Well, what? 6%? Okay, Janet thinks 6%. What's that? 34? How do you get 34? Half of 68. That's absolutely right. Right? Because one standard deviation, 50% is going to be 1 standard deviation above. 1/2 of that percentage is going to be 1 standard deviation below. Okay? So we should get 34%. Does that make sense to everybody here? Yeah? Okay. All right. Let's look at C. What percentage of the math scores are less than Natalie's score? What percentage of the scores are less than Natalie's score? So let's finish this out. Just, we've got 5, 7. So we want to know not only that, but how many of, or what percentage are from here to here? Okay. Well, let me explain how we do this. All right. The first thing that we're going to do is we're going to take 99.7 and divide it by 2, right? Because that's going to get me from 41 to 23, correct? Yep. All right, so 99.7 divided by 2. What is that? Okay, 48.85, is that what you said? 49.85. Okay. All right, so that's getting from 41 to 23, but I also have to include this little bit right there, which was what percent? Plus 34. Okay. So what's 49.85 plus 34? What was that? Okay, let's go ahead and round that up to the nearest whole. 84%? 84%. Okay. You said it was 83.85. All right, we're going to round that on up. Okay, does that make sense on how we found that? Hopefully. All right, let's look at question D. How are we doing on time? We got like 4 minutes. Okay. Let's see. Micah received a score of 43 on the math portion and a score of 80 on the science portion. Find the z-score for each of Micah's scores. All right, so we have to kind of do this twice, right? On the math, he received a 43. So what math am I going to do there? We want the z-score of his math. His math was a 43. 43 minus 41 divided by 6. Okay? So 43 minus 41 should be what, 2? So what's 2 divided by 6 as a decimal? Probably 2 6 is going to be what, 0.6 repeating? Or 0.3 repeating, right? Because it reduces to 1/3. All right. So we should get 0.3 repeating for math. Okay, let's look at his science. What was his science score? What was his science score? 80. Well, we've got to work on some of our reading, right? 80 minus what? 66, because we're going to subtract the mean. What was the standard deviation there? 8. So we want 80 minus 66 divided by 8. Well, what is that going to be? Probably what? 14 divided by 8. You get 1.75. I got 1.75, but maybe I'm wrong. Does it round up? No? It's just 1.74? Okay, 1.75 for science. Okay? We got one last portion here, right, on E. On which portion did Micah score better compared to the rest of the class? The 80 in science or the 43 in math? The 80 in science, right? The science portion. All right, so we would say E is science. We feel good enough to be able to do the homework here. Okay? All right. I'm looking at the rest of these, and I think you guys can do this. On number 7, it's that same thing where you're going to get that 34% again. And on 8, you're finding the z-score. Okay? All right. All right, very good. Thank you guys for your attention today, and we'll see you on Monday.